Hey everybody, just a short video today or tonight, just so that I can touch on a few points from assignment 11. I don't know why everybody says I'm dyslexic. Assignment 11. Antiderivatives and differentials. I just want to draw your attention to a couple of exercises that maybe about a third of the class had trouble with. So I'm just going to touch on those exercises. This is going to be a very short video. Here's a good exercise to look at. And it addresses, among other things, an issue that might be in the instructional videos that I've posted on my website, and then again, maybe not. For a lot of properties of antiderivatives, those properties of antiderivatives are the analogs of properties of derivatives. For example, when we compute the derivative of a polynomial, essentially we do it term by term by term. The derivative of a sum or difference is the sum or difference of the derivatives. And the same holds for antiderivatives. When we compute an antiderivative or an integral, we compute the antiderivative term by term by term. So the antiderivative of a sum or difference is the sum or difference of the antiderivatives. And we have the property that the derivative of a constant times a function is equal to the constant times the derivative of the function. So when we compute the derivative of a constant times a function, we write the constant down, and then we compute the derivative of the function and we multiply them together. The same thing holds for antiderivatives. The antiderivative of a constant times a function is the constant times the antiderivative of the function. So if we compute the antiderivative of a constant times a function, we write the constant down, we compute the antiderivative of the function, and we multiply them together. So the number of the properties of derivatives, there's a corresponding analog or analogous property with antiderivatives. But with products and quotients, all of that ends. And when we had this assignment number 11, we didn't know that. Now, we hadn't been misled. Nowhere in the book and nowhere in my videos did I tell anybody that there's some sort of product rule for the antiderivatives of products. And I didn't tell anybody that there's a quotient rule for the antiderivatives of quotients. Nevertheless, we have an antiderivative of a quotient here. But in the book, did it ever give us a quotient rule for the antiderivative of quotients? Did I ever give you a quotient rule for the antiderivative of quotients? Nope, because there isn't one. There is no formula for computing the antiderivative of a quotient in general. Now, if that's the case, why did they give us an exercise like this right when we're just starting to do antiderivatives? Well, I'll tell you why. They wanted us to get this wrong so that we'd get good and mad about it. And we'd get so mad about it that we'd never make that mistake again. I'm sure that's the reason, really. They wanted us to learn our lesson, and sometimes we don't learn a lesson unless it hurts. They wanted us to try to use some sort of quotient rule on this, or compute the antiderivative of the numerator and the antiderivative of the denominator and put one over the other and get the wrong answer. And they wanted us to get really mad about it so that we'd learn once and for all time that there is no quotient rule for antiderivatives. Now, if that's the case, then how on earth are we going to do this? We've got to rewrite it. And I'm sure in my videos I've told you that the word rewrite is one of my favorite words. It's such a favorite of mine. Well, let's see. I'm going to write it in red mark. That's how much I like the word rewrite. And sometimes in math, we really have to do this. Now, the first thing that I'm going to do, I'm going to get rid of this radical. And I'm going to write it in exponential form. Now, it looks nicer, but I still haven't addressed the fact that we have the antiderivative or the integral of a quotient. And I like this word rewrite so much that I'm going to write it again. I don't know in general how to compute the antiderivative of a quotient. So I'm going to take each term of the numerator and write it separately over the denominator. Whoops, that's not right. Looking good, looking good, looking good. Hey, you know what? I think I'm going to rewrite this son of a gun one more time. X to the first over x to the 1/2. We have the same base x. We have the quotient of x to two different powers. What are the exponents going to do? Right, they're going to subtract. I'm going to get x to the 1 minus 1/2. The exponents subtract, and that gives me x to the 1/2. So that's my first term, x to the 1/2. And I can rewrite this as 3 times x to the negative 1/2. Let's see, 3 over x to the 1/2. That's 3 times 1 over x to the 1/2. If we bring this up to the numerator, we have to change the sign of the exponent. So this thing, 3 over x to the 1/2, is 3 times x to the negative 1/2. Oh my goodness. Now, this is in the form of something that we can integrate. First term, add 1 to the exponent. Divide by the new exponent. That takes care of our first term. Second term, write the constant down. Add 1 to the exponent. Divide by the new exponent. And add that plus c. And I really should rewrite this. And I'll tell you what, let me make this a big capital C, because that's something else that I saw on the WebAssign assignments, and this really did bother me. If we write plus C and it's not a capital C, it's going to mark the whole thing wrong. So in WebAssign, let's make sure that we add a plus capital C here. Dividing by 3/2 is the same as multiplying by the reciprocal, 2/3. Dividing by 1/2 is the same as multiplying by its reciprocal, which is 2. And there's our answer. Voila. Now that was pretty easy. The next one's going to be even easier. And it's almost a mindless process, but I'm going to emphasize it because some of us did get this exercises 13 and 14 incorrect, the differentials exercise. Those were the easiest exercises of the set, and somehow we got them wrong. And I'm going to emphasize those because when we do U substitution, which we are going to do in this course, if we don't know how to compute differentials, we can't do U substitution. And we need to know how to do U substitution for our final exam. And for those of us who are taking Cal 2, we need to know how to do U substitution. If we don't, we're going to get our butts kicked clear to here to Oklahoma. On the other hand, if we have a fairly good handle on U substitution coming out of Cal 1, and we take Cal 2, that will take us an awfully long way in Cal 2. This is one of the things in Cal 1 that if we learn U substitution, we're going to do pretty good in Cal 2. If we don't learn U substitution well in Cal 1, we're going to get clobbered in Cal 2. And one thing we have to know to do U substitution is differentials, which is the next thing that we're about to do. Here's our exercise. Y equals 8x squared minus 9. Compute the differential of y. That is, compute dy. Now, there is a theoretical aspect to computing differentials. We don't care about that right now. At this stage of the game in Cal 1 and also in Cal 2, our interest in differentials is strictly computational. All we care about is how do we compute a differential. And that's going to be very important when we do U substitution. Here we go. First step. differentiate both sides with respect to x. Okay, let's see. The derivative of y with respect to x, well, son of a gun, it's just dy dx. And the derivative with respect to x of 8x squared is just 16x. The derivative of 9 is 0. It's a constant. First step accomplished. Now our second step. Multiply both sides by the differential dx. And here we're just going to consider dy dx to be a formal quotient for the sake of computation. So here's what we're going to get. Multiply both sides by the differential dx. And we get the differential dy equals 16x dx. And that, believe it or not, is the whole process. We are done, boys and girls. And as I said, there is a theoretical aspect to differentials and so forth. We don't care about that right now. Our interest in differentials has to do solely with its application to U substitution, which you may actually be working on right now. This is it. Now you're looking at this exercise and you're saying, I must be missing something. It can't be that simple. Well, you know what? This is one of those rare cases where it is actually as simple as it appears. We're not missing anything. This is strictly a computational exercise. But if we don't know how to do this, then we won't do well in U substitution. And if we don't do well in U substitution, we're going to get our butts kicked in Cal 2. And we may have a little bit of a butt kicking in our final exam in Cal 1. It's simple stuff. It's just as simple as it appears. Know it. It's important. Just because it's simple doesn't mean it's not important. Know how to do this. The next topic, U substitution, depends heavily on our being able to do this. And that, folks, is the video.